Yeah, I'm here. Wow, what's up? I'm just watching something, that's all. You changed your profile pic yet? Should always be 5 seconds. It's like 5 seconds. If it's on live, if your internet is a bit slower, it's probably around 10 seconds. That's great. That's great, dude. I was forced to not make due dates anymore. All teachers are now not able to give you guys due dates. Well, science teachers at least. No, a lot of students complained that no, so a lot of students complain that they have too much work they do, that their other teachers are giving them really a lot of work. But I feel like that's mainly because they didn't do work in class in the first place. So of course, any work is too much work. And so their parents called the school, complained, and now, well, at least the science department can't the science department can't give you guys due dates anymore. We can't give you deadlines. We can't penalize you for being late. But you should still do them because you don't want everything piling up. Like if you take like 30 minutes to do something each day, just do it each day. You don't want things piling up. Um, that's because I'm too lazy to change the rubric. I even put in the comment under the assignment homework now that I won't take off points for being late. Me, it says on the rubric on time is worth 1 point. I'm too lazy to change it. That's it. It's too tedious because if I change the rubric, then I have to redo all your points first off, and that's just not worth it. That's why there's a survey. That's why I put out a survey. Like, how much time do you spend on like science homework? Thankfully, none of you guys. There's only one person in this class that has spent more than 60 minutes per day on my homework. Everyone else has spent a normal class time on my homework. Yeah, I mean, that's fine. It always goes up at 1. It's always scheduled to go up at 1. Hello, how are you doing, Roida? As expected, only some of the better. Wait. Yeah, you're gonna get a test. You're gonna get a test for Google Forms. and there's gonna be everyone's gonna get a different version. Well, not yeah, everyone's gonna get a different version. I mean, I'm not gonna tell them though. I mean, I told you guys, but you're gonna keep that quiet. Everyone gets a different version. So if someone happens to copy the same answer, they're just gonna get it wrong. Again, they won't know. Like it's a pretty easy 100 to be honest. But I do some of the half of them are short answer questions, so you do have to explain your logic. It's meant to be. If you've been paying attention, it's meant to be an easy grade. Or rather, if you've been diligently listening to lessons, it's you should be getting hundreds. And if you haven't, if you've just been looking at me writing down the answers, then I don't think you're gonna do well because then you're gonna. But then again, you don't have a time limit on it, so you can take as much time as you want. It's it's not meant to be an actual test, but it's like a substitute. Like, what can I do, right? I can't put a deadline on it because I can't put deadlines on anything, which is unfortunate. I can't put deadlines on any of my assessments now, so you can take as much time as possible. We'll start at 110. Does it say 110? Yeah, it says 110. Great. We're actually doing two lessons today. The second lesson is fairly short though. That's why. That's the thing I want to hate the most. Yeah. I mean the numbers change. The numbers change. The multiple choice questions are like a giveaway. To be honest, I expect like given the fact that you have as much time to complete the multiple choice questions, none of you guys should get it wrong. Um, and then some of the calculation questions are a given too. To be honest, the only place I think I'll be able to get points off of you guys is the short answer, whether or not you're explaining correctly or not. But even then, you have the limited unlimited amount of time to complete them. Like I'm not. It's pretty. Like you guys have as much time to complete it as possible. So Irissa is early? That's amazing. That's wait, you're not really early. You're like 3 minutes. It's 103 right now. 104. What's up, Rio? I know, Arissa. Thank you for showing up. I appreciate it. Iris? You want to be called Iris? Is there a reason your last name is Mulani? Mulani? I mean, not your last name, but your last name on your account. There's a planet inside the Earth. Earth is the planet. Four more minutes. I think I see the consistent people that show up now. It's usually Roida, Farihia, Irissa, Tahira. I mean, Tahira goes MIA in like in the middle. Tommy shows up once in a while. Joshua might show up late. Who are other people? Jareen. Why is Jareen here? Me and Miss Butler are at different points in the curriculum, I think. We're at different points in the curriculum. Oh, you missed yesterday's stream, Tommy? Okay. I didn't realize. Because the Castle Learning homework. First of all, Capsule Learning is so buggy and so slow. I stopped using it. I don't even care about it anymore. And what I noticed was students usually just copy pasted the Castle Learning explanations onto your Google Doc. That's what I noticed. So, which is weird because I go through the explanations in the video. So when students copy the explanations of Castle Learning, they probably didn't watch the video at all. So what's the point? Like if you're copying down, if you're watching my video and you're copying down the explanations, at least maybe you're learning something. But if all you're doing is copy pasting from Cast Learning, you're not learning anything. So I just remove Cast Learning. Yeah, I'm a little bit further, a little bit further, but it doesn't matter in the grand scheme of things. I want to. What do you mean if I teach AP Physics, what do I want to do? Which one would you do? What? What do you mean? I don't know if I'm teaching AP Physics yet. It's always whatever one comes first, because you can't do what's is it, A, B, B, C? It would be the simple one. It would be the first one, obviously. It definitely wouldn't be calculus. You would still be using algebra. I think you would do. I think it's called BC. BC, right? BC. I'm not gonna say that, Arissa. There's no way I'm saying that. Ah, okay, okay. Ah, okay, okay. There is physics BC though. Physics BC, whatever. I don't know. It'd be a simpler one. It'd be the first one. It'd be the one that's focusing on more mechanics than electromagnetics. All right, let's get started. Let's get started. So, in no, I don't know what I don't know why would I would say that, but let's get started. Let me remove this overlay too. It's not really an overlay. Uh, so let's take a look at this question right here. All right, so on Regents questions, it can ask you a type of question, like number 6, right? So they can ask you which circuit diagram below correctly shows the connection of ammeter A and voltmeter V to measure the current through and potential difference across resistor. Like what the hell does this question mean, right? Let's go step by step through what this question actually means. Ammeter. So there's a certain thing ammeter means. Hold on, I think it's this one. Ammeters measures currents, right? So ammeters measure current, which is it's kind of hinted at the name. It's a meter, right? And it's so amperes. So it's a meter that measures amperes, right? So it measures electric current, all right? So ammeters are things that measure electric current. And in a diagram on your regions, they're represented by the letter A, all right? And now what's voltmeter? I think it's pretty self-explanatory now. I've given you a hint. Voltmeters measure voltage, right? They measure volts, so they measure voltage. So ammeters measures current and voltmeters measures voltage. All right? So if we were in if we were able to have lab and we were at school, right? If we were able to have lab and we were at school, this is what we would see. And so we would use a circuit board right here. Instead of ammeters, we would use this current probe, right? Because this connects to your LabQuest, and we would use this. And this would be a voltage probe, and this would also connect to our LabQuest, and this would also measure a voltage. All right, both of these would connect to LabQuest, and And these are called multimeters. Multimeters being that they measure multiple quantities, right? It's hinted at in the name. This is I use some type of these. Ooh, I remember this one. This is what I use in university. I use this one. No, not that one. It looks similar. It definitely it was one of these. It was one of those. So we use multimeters in university. Now, so we don't really split it. I think they used to split it like way back when, because ammeters look like this. Actually, if you think about it in old classrooms, you see this on the top, like right on the top of the chalkboard. So they're like huge circles of it. They're really old though. So these are ammeters, and these are voltmeters. But modern, we just use multimeters now. Modern tools, we just use multimeters. So which is why I don't understand why they still use ammeters and voltmeters in your regions. But that's not important. The only thing that's important is that ammeters measure current and voltmeters measures voltage. Now, now that we know what ammeters and voltmeters are, where do we want to connect them to properly measure current and voltage? Because again, if you take a look at these current probes, they have connections. You want to connect them somewhere. You want to connect them somewhere on your circuit board to properly measure current and voltage. But where do you measure them? Right? Where do we measure? Where do we put the current probes and where do we put the voltage probes to properly measure current and voltage? So let's start with current first. Let's start with let's start with how to properly measure current. Now, where is my reference table? So also this right here is a simulation. It's on PhET. I put the link to the simulation on the assignment, so you can go to the simulation and play with circuits yourself. So, and then again, you see electrons are going through here and they're moving across the circuit. And if I click this conventional tab, right, conventionally they go the other way, right? But electrons are the one that's moving. But if you're going to look at it conventionally, it's just the opposite. But again, electrons go from negative side to the positive side. And batteries are represented like this, right? So the long side is the positive side, the short side is the negative side. Now, where do I want to put? Again, this is a current probe right here, the thing I'm moving. Where do I put this current probe to accurately measure the current running through a circuit or through a resistor? And again, a resistor can be a light bulb. Anything that has electricity running through it is a resistor. So where do I properly put this current probe? Well, let's take a look at this. If I want to know what my current running through a resistor is, well, then I just put it in a series circuit. Because I know that in my series circuit, I know that my current is equal to the current running through each of these resistors. So it doesn't matter where I put it, I want to put my current probe in series. So if you see here, the current reading here is 1.67. Current reading here is 1.67. Current reading here is 1.67 as well. It doesn't matter where I put it, as long as I put my current probe in series, I get my current. Doesn't matter where I put it. So where do I put my current probe to properly measure current? I must put it in series. Because it says right here. Right? I want to measure my current, so I would put in series. Well, that's a series circuit. Let's take a look at a parallel circuit. Where would I put my current probe if this is a parallel circuit right now. Because again, this is a parallel circuit. Let me actually just move it over. Let's move this over. It's kind of a like a scuffed parallel circuit, but it's good enough. Um, yeah. So if the question asks you, what is the current running through light bulb 1, right? What is the current running through light bulb 1? Well, we know that if my current is in series, then my current is equal to each other, which means that I want to connect my current probe in series to this light bulb. And that's how it actually measure the current running through my light bulb. I'd have to connect it in series. But if a question asked you, well, and again, you see this over here as well. This is in series as well. So this light bulb also has a current of 1 amp running through it. But if the question asks you, well, what is my total current running through this circuit? What is my total current? Well, I can't put it here now because this is only measuring one resistor. I'd have to put it in series at the end. So after these two wires combine, then I can put my current probe here, and this would measure the total current of my circuit. Alternatively, you can put it at the beginning, right? You can put it at the beginning before they even separate into two circuits, right? And this would measure your total current. This would measure your total current. Rorita says, does it matter which side of the light bulb the ammeter is? No, it does not. It does not. It does not at all. It doesn't matter what side of the light bulb the ammeter is, because if you connect something in series, you know that your current is the same. Like if you connect any current in series, you know that the current running through each of them is the same. It doesn't matter. This is, again, this is a lot of figuring this out, figuring where to put in, yeah, but not in parallel. Because in parallel, well then, your current just gets split. It, if you want the current for a single resistor, yeah, put it in series here. If you want the current for the total current, put it at the end or at the beginning. So understanding this, understanding where to put ammeters relies on two things. It relies on the first concept, right? This is the first concept. You have to figure out that, well, in a series circuit, that my current, if I connect something in series, my current is the same throughout. This is the first concept you must understand. I'll talk about voltmeters. Again, this is the first concept you must understand, that my current is the same in series circuits. So I must connect my current probe in series to properly measure current. So now let's talk about voltmeters. Nothing. It'll be the same. It'll be the same, Rosita. Oh, what happens if you put it under it in parallel? Well, it just decreases. Because what's happening here is you've just doubled the routes. You've doubled the circuit, right? So all you did here was decrease the current. Because if you connect something in pair, you'll see this decrease. Now, I don't know why the current is changing, but it is. But hey, I mean, I have an idea why it's changing, but I don't know why it's changing in a simulation. Oh, okay. I know. I understand what's happening here. It's because There's no resistance on the ammeter. Hold on. I understand what's happening here. It's because if you connected before the light bulb, there's no resistance through the ammeter. Alright, there's no resistance through the ammeter. What's gonna happen is that all the electrons are gonna want to go through the ammeter, because the light bulb has a resistance, right? And because you're connecting the current probe before the light bulb, the electrons there's no resistance in your current probe, so the electrons are just gonna go through that no resistance circuit. And because there's a resistance in your light bulb, uh, it's not gonna go through the light bulb, right? It doesn't want to go through the light bulb. It wants to go through the path of least resistance. So in any case, oh yeah, the ammeter would still be connected to the light bulb. Yeah. No, yeah, you're right. Yeah, it still would be the same because it's still in series, right? Because it's still in series, so you're gonna read the same current. So it's still gonna be the same current. As long as you're connecting something in series, you will measure the current correctly. As long as it's in series. So this is in series. It's measuring the total current of the circuit. This is also in series, but this is only measuring the light bulb, the current running through the light bulb, because it's not connected to anything else. All right, let's talk about voltage now. And so the voltage of this battery is okay. Well, let's go here. Only so in parallel circuits, your voltage is only equal to each other when you connect something in parallel. So what's the proper way to connect something to connect a voltmeter? Well, you have to connect it in parallel because it will give you the same voltage reading, right? So you have to connect the voltmeters in parallel because all the voltage will be equal to each other. So if I connect this right here, again, the black one goes in where the electrons come in, and the red one goes in where electrons come out. All right, or rather, pass through, that is. Because if you switch, yeah. So you're gonna get a voltage here of 1.67 volts, which is going through this light bulb. Again, in a series circuit, which is what this side is, your total voltage is equal to all the individual voltages combined. The voltage of this battery right here is 5 volts. So that means that the voltage going through this light bulb is 1.67. Through this light bulb is 1.67. And through this light bulb as well is 1.67. So the voltage difference, they all add up. All three of these voltages add up to 5. Well, and again, if we want to properly measure voltage, we have to put them in parallel. So the voltage in this parallel circuit of this light bulb right here is 1 volts, right? So it's parallel, and so it's 1 volts. And if we measure the voltage across this one that's also parallel, it's also 1 volts. All right, so the voltage is still 1 volts. And that's how you would measure. That's where you put a voltmeter. You have to put voltmeters in parallel because you know that when things are in parallel, their voltages are the same. So you must put a voltmeter in parallel. And that's really just going off these formulas right here. So you know that in series your current is the same, so your ammeter must be in the series. In a parallel circuit, your voltage is the same, so your voltmeter must be in parallel. Any questions? If there are no more questions, I'm just going to move on to problem solving. Yeah, I would read 3.33. You're right. Because it's measuring the voltage difference, right? It's measuring the difference in voltage. It would be 3.33. Do 6. I mean, okay. I'll do 6 first, I guess. Sure. I'm glad you came to that conclusion yourself. All right, let's do 6. Now, if you don't really understand it, if you don't really understand it conceptually, because again, I don't really expect you to get this like right away, because it takes a lot of memory. Your homeworks have no due date. I changed it. Your homeworks have no due date anymore. You should still do them without letting it pile up, but they don't have due dates anymore. Um, so let's look at 6, right? Let's take a look at 6. So, which circuit diagram below correctly shows the connection of ammeter A, right, and voltmeter V to measure the current through and potential difference across resistor R? So you only care about R. So you only care about resistor R. So again, you want your ammeter in series, right, to R. You want your ammeter in series to R, and you want your voltmeter. Tommy wants me to do 6 first, so I'm gonna do 6, and then I'll do the rest. And you want, oh, you don't, I'm sorry. And you want your voltmeter. I don't know. I don't know exactly. I don't know for you. And you want your voltmeter in parallel, right? So if you don't remember anything else, you just have to remember this. You just have to remember that your ammeter must be in series and that your voltmeter must be parallel to whatever thing you want to measure from. So A is wrong. Choice A is wrong because you have A in series, right? This is in parallel to resist R. So this can't happen. A cannot be in parallel. It cannot be in parallel. So choice A is wrong. Choice B is saying that you have a voltmeter in series, right? This is saying that your voltmeter is in series. That's impossible. You cannot have a voltmeter in series if you want to measure the voltage through R. So B is wrong as well. C is the same exact. C is oh, okay. So C and D is what's left. Now, here's a tricky thing in C, in choice C. You want the current running through resistor R. But if you put and so if you correctly wanted to measure your current running through resistor R, you would put it in series either here or over here, right? You either put your current probe in front of your resistor or behind your resistor or behind. And so this right here, this placement of your ammeter is wrong. The placement of the voltmeter is correct, right? Because you want it to be parallel, but the placement of your ammeter is wrong. You want your ammeter in series. It has to be either before your resistor or after your resistor. It cannot be over here. It cannot be over here, right? So even though the voltmeter placement is correct, your ammeter placement is wrong. And so D is the only thing left, right? So D is the only thing left. So it correctly places the ammeter, right? Oh yeah, I forgot to say that your ammeter can also be over here, right? Your ammeter can also be over here, or your ammeter can also be over there, right? It can be in any place, and your voltmeter can also be over there. All right. So choice D fulfills everything. A is in series, your ammeter is in series, and your voltmeter is in parallel. So that is correct. So that gives you correct answer. Let's do one now. Number one says, in which electric circuit would the voltmeter read 10 volts? So again, your voltmeter to correctly read 10 volts has to be parallel. It has to be parallel. It can't be any other thing. Give me a second. I gotta cough. All right, all right. I'm back. I'm back to it. Now, number one. Number one. Choice A. Let's look at choice A. I think it's easier to think about. Um, I think it's easier to think about it without actually including the voltmeter. So let's actually do this, draw this without including the voltmeter. So this would be 20 volts. Okay. It must be parallel, but this is going to read something else. So because you're splitting this into two parallel circuits, I mean two parallel resisted, connecting something in parallel, this is going to have the same voltage, right? So this is also 20 volts. The voltage across the resistor is 20 volts, and the voltage across the other resistor is 20 volts, which means that if you connect, you also connect a voltmeter in parallel in the top. That means that voltmeter also reads 20 volts. Which is wrong though. You don't want to read 20 volts. You want to read 10 volts. The question wants 10 volts. So choice A is wrong. Even though choice A is saying has the correct placement for your voltmeter, it's reading the wrong voltage. It's reading 20 volts. So choice A is wrong. Choice B for number one. Right, choice B for number one. Yeah, let's draw this without the voltmeter. 20 volts. This is in series. But let's see what the voltmeter here says. Since you know that in a where's my reference table? Oh yeah, right here. You know that in a series circuit, yeah. So B also has 20 volts. Also reads 20 volts. But in the series circuit, your voltage is equal to every single one combined. So this resistor, the first resistor has a voltage of 10 volts, and this one has a voltage of 10 volts. But because the voltmeter is connected to both before and after, because it's connected to both before and after, what this voltmeter is going to read, this voltmeter is also going to read 20 volts. So that can't be it either. Let's look at C. So again, let's ignore the voltmeter for now. We don't really need the voltmeter because that's just going to confuse us, or rather you guys. It's not us, just you guys. Uh, Flex, yeah, yeah. Okay. So because again, this is connected in series, the total voltage is V1 plus V2, right? So this means that this is 5 volts and this is 5 volts. But this voltmeter is only connected to this one, to this resistor, in parallel to this resistor only, which means that my voltage here is 5 volts, right? This voltmeter is reading only parallel to this resistor, and this resistor only has a voltage of 5 volts, which means that the voltmeter only reads a reading of 5 volts here. Because again, this is in series, so you're splitting the voltage, but then you're connecting the voltmeter in parallel, which means that the reading for this voltmeter is the same as this one. So C is wrong as well. It's reading 5 volts. And so the only choice left here, now is choice D, and obviously that's the correct answer. But let's explain why it's the correct answer, right? Let's explain why it's the correct answer. So again, this is connected in series, which means that this is 5 volts, this is 5 volts. But because my voltmeter is connected in parallel to prior, right? It's connected at the beginning, at the end of these two resistors. My voltmeter has a reading of 10 volts because it's connected in parallel to this entire thing. Yeah, Joshua, no assignments have due dates now. Because there was a complaint about like the science department giving out too many homework assignments. Or rather, not too many homework assignments, too much work. I don't know, but my Google survey from this morning says that that's not the case for my class at least. For my classes, you guys seem to not be spending more than 45 minutes on one assignment, so I'm good. I'm out of the clear. I can show Walsh something, right? Like I can show my AP that I have proof that my students don't think that that's not a problem with my classes. Maybe it's a problem with other classes, it's not a problem with my classes. Yeah, but unless I'm not gonna, I'm not gonna get in trouble because my AP says, my AP says I cannot put deadlines on any assignments, and unless he says otherwise, I am not gonna change it. I'm not gonna get in trouble. All right, I have a boss too, guys. I have a boss, and I'm not gonna get in trouble with my boss. All right, let's look at number two. Yeah, I gave you guys the same thing. Uh, let's do this. Let's do number two. So again, let's look at the circuit. Let's look at the circuit. This is 3 ohms. This is 12 volts. The diagrams don't show. I'll see if I can fix it. If you don't, just look at the PDF as well, though. You can look at the PDF. So your resistance is 3 ohms. Your voltage is 12 volts. And using the formula R is equal to V over I, if you plug in all your numbers, right? 3 is 12 over I times I times I, 3I, 12, 3. I is going to be 4 amps. So your current here is going to be 4 amps. Now, where do I want to put my ammeter and voltmeter if I want to measure a current of 4 amps and I want to measure a voltage of 12 volts? Well, again, you want your ammeter You want your ammeter in series. You want your ammeter in series. And you want your voltmeter in parallel. So for you to get a current of 4 amperes, X is in series, so X has to be your ammeter, and Y is connected in parallel, so that has to be your voltmeter. So Y measures, what the hell? So Y measures 12 volts and X measures 4 amps. So the choice is D. Because again, you want your ammeter in series and you want your voltmeter in parallel. So the answer choice is D. 3 operates under the same logic. So number 3 is saying, where should an ammeter be located to correctly measure the total current, and where should a voltmeter be located to correctly measure the total voltage? So again, you want your ammeter, and this is number 3, you want your ammeter in series, and you want your voltmeter in parallel, right? You want a voltmeter in parallel. So you want your ammeter in series and you want a voltmeter in parallel. For the entire circuit, by the way, for the entire circuit. So already choices 4 and 3 don't make sense, right? You don't want your ammeter at position 3 or position 4 because they're in parallel. So it's either going to be 1 or 2. So is it either at position 1 or at position 2? So position 1, well, let's talk about position 2 first. When you place your ammeter at position 2, the only thing that you're measuring is the current running through this resistor. So you're measuring the current running through this resistor only if you place that at 2. But the question wants the entire circuit. The entire circuit. They want the total current. They want total current. So if you want total current, you have to place it either at the beginning, which is where 1 is, or over here at the end, right? You want to place it before it separates or after it combines. So it's either going to be over here or over here. That's the correct place to put it, right? So position 1 is the correct place to put an ammeter. Now what about voltmeters? What about voltmeters? So ammeter in the series is going to be number 1. So where do you want to put a voltmeter? So it's either going to be choice 4 or choice 3, because those are the only ones in parallel. So either choice 4 or choice 3. Well, 3 is only measuring the voltage of this resistor. So this resistor right here, you're only measuring the second voltage. If you want to properly measure the voltage of the entire circuit, you have to put your voltage, your voltmeter, parallel to your battery. So only 4 is the correct answer. To measure the voltage of the entire circuit, it must be parallel to your battery. This voltmeter right here is only measuring the voltage running through one resistor. If you want the entire circuit, it must be parallel to your battery. So number 4. So the answer choice is A. Answer choice is A. Again, so for 4, 5, 6, 7, I mean, I think you only have a problem with 5, to be honest. Yeah, I think you only have a problem with 5. So 5 is, Well, when you get to it, you'll get to it and you'll figure it out and you'll ask me questions. Um, but for now, just know that your ammeter, if you whatever for whatever you're measuring, your ammeter must be in series. Your ammeter must be in series, and your voltmeter must be in parallel. And so that's how you answer the rest of the questions. The only question I see you having problems with would be five, but five just takes a little bit of like thinking, and you should be able to figure it out. So any questions? I'll still be here. Series means it's connected in. Hold on. Right there. Right there, Arissa. Also, if you need help with the other thing, other homework, any of you, just let me know. I think the video that I made on it should be sufficient though. What are you talking about? You have to explain. You still have to explain your answers. I mean, I guess an explanation of ambient series and voltmeter in parallel works just fine, to be honest. That's a good enough explanation. If you want to explain more, go ahead. That shows me that you truly understand it, but then it should be fine if you only say ambient series, voltmeter in parallel.